This is the second part of Lecture 3, and we're continuing on our journey assembly language programming introduction just to get you a feel for it. So let's crank through this. Not sure if this will fit into one video or not. So this is your high-level architecture of a computer. Three components here: memory, I/O, and a processor. The idea here is the instructions are essentially going to be controlling the transfer of data around these three structures here, and that's what we want to look at in this issue. The issue is there's only three boxes there. There's really not that much data transfer that can go on, so it's after you get used to it, it's really not overly complicated. So this is our instruction set. These are the resources, the hardware resources that the programmer has control over. So the instructions are used to control these resources. This is the programming model. So we've seen that a couple times. Implication there, it's pretty important. So this is our first assembly language program. You don't need to know anything about it really. What I want to show you is there's essentially three parts to it, and we'll go over those parts in a minute. So there's this part's right here. These are comments. These are comments also. Looks anything after a pound sign is ignored by the assembler. So a comment is a message from a human to another human. Doesn't make your code longer, makes your code more readable for humans. Second thing we have here is a assembler directive. Assembler directive is a message from the programmer, which is a human, to the assembler, which is a piece of software. Okay, so there's no need to worry about that now. Next thing we have here is the actual instructions. So these are the actual instructions right here. I guess it's everything like that. Those are the instructions we need to get that we'll be learning about. And also here, I never really know how to classify these. These are labels. So the instructions are messages from the programmer to the hardware. These are kind of comments, kind of messages to the assembler. I really can't classify these too well. We'll talk about that more later. So once again, got comments, we got instructions, more comments, I got labels, and we got an assembler directive. So this is kind of hammering down what we said before. Comments are messages from the from the human to another human, programmer to another programmer. The directives, message from the programmer to the assembler, and the assembly code itself is a message from the programmer to the computer. So here it is. Once again, the program, now that we've talked about it, is we've got what do we have? These are comments, more comments, and yeah, these are instructions and labels and a directive. But more importantly, what you see in this code is it's just absolutely beautiful looking code. Everything's lined up super nicely. Check it out. Labels start in the first column. All the instructions are lined up. The first operand in the instructions lined up. And I got, this looks bizarre, of course, but to kind of handle the complexity of this, you keep everything aligned super nicely when you're writing assembly language code. So what the instructions do at a high level, they do something. Essentially, they tell the microcontroller to go somewhere and do something, essentially to transfer data around in these blocks. So essentially, in that context, what we have here is the I/O block. It transfers data in and out of this thing. The CPU crunches bits. The memory stores data. I can actually get data from memory. So this is a memory that I can read and write, and the instructions actually tell the code to go somewhere and do something else. So once again, I can actually do something, or I can tell the programmer to go somewhere and do something else. So that means these are essentially branches. So instructions, I don't really do anything except go somewhere else. and you'll see that coming up. So embedded systems programming, this is embedded systems programming all the way. Essentially the structure of the program is such that it doesn't ever stop running. There's no halt instruction. Once you start it, it's always executing instructions in one way or another. So there's always an issue of you're writing assembly language code. Is it software or is it firmware? Essentially, typically speaking, we're writing firmware because it's specific to a piece of hardware. So we're writing programs that are specific to that Basis 3 board. Generally speaking, that means it's not going to run on any other development board. So that makes it firmware. Specific to hardware makes it firmware. Otherwise, if I'm writing a program that's going to run on every computer on the planet, it's going to be software. There's two types of instructions in the instruction set. They are these, ABI instructions. I just call them normal instructions, but then there's also pseudo instructions. Okay, so we're in charge of implementing the real instructions, and from the real instructions, you can actually take that back. Okay, so there's actually pseudo instructions that the compiler switches or makes into or translates into a real instruction. So the pseudo instructions are there. You can use them, but they are not implemented in hardware. The assembler translates them to real instructions. So there's about 40 real instructions, and there's about 20 more pseudo instructions. And I think we saw that before. You didn't really know it, but in this, kind of the ones that are dark, which you can't really see, are actually pseudo instructions. No need to worry about that. We'll get into it later. So this is RISC-V Otter instruction classification. There's not that many instructions. Look, program control or program flow control is essentially like a jump and a branch. You're used to that from your higher level language. A whole bunch of instructions like that. There's operations that crunch bits like add, subtract, and, or, etc., etc. There's data. There's instructions that move data around from memory, which includes I/O. We'll get into that later. And then there's just a couple auxiliary instructions. There's not that many instructions. It seems overwhelming at first, but once you get a handle on it, you'll think, wow, a lot of these instructions are similar and do the same thing. So these are the hardware itself has, this is the programming model, it has 32 general purpose registers and a bunch of memory. We'll say a bunch of memory. So the general purpose registers are how it grinds the bits. So that's like a lot of registers, but sometimes you need to put some of that data into memory here. So the memory itself is divided into a couple areas. It's one memory that shares the program and the data on this thing. So generally speaking, our instructions are going to be associated with moving data around, but we have this nice little register file that's going to be doing the number crunching. If I run out of registers, I can transfer the data into main memory. So these are this is the form of the instructions. These are a couple different instruction types. This is an instruction that has no operands. This is an instruction that has one operand, two operands, and three operands. So these are the flavors of instructions. These we'll say these are the instructions. These are the operands, which is 0, 1, and 2, and 3 operands. So generally speaking, what's going on here is this RD typically means, not typically, but it means the destination register. RS is the source register. So in some of these we have 2 source registers. In some of them we have 1 source register, depending on what instruction it is and what type of instruction that is. So we can, the source registers, destination registers here can be any one of the 32 registers, which is actually not right. I shouldn't have said that. So you can use our X0 as a source register, but not a destination register. X0 is a register. It's always at 0. So we're talking about levels of memory here, and So I didn't make it. I got a couple more slides here. I don't want to make this too long, so I'm going to go ahead and break it here and start the next lecture right at this point. Start the next video. Okay.